In this section, we're going to look at how to pull a random sample from your data. First, ensure the customer database is open in the database window and that data is selected in the Properties window. Click the Analysis tab, then select Random in the sample group. This is the Random Record Sampling dialog box. Enter the number of records you want to select. In this case, I want 10, and accept the random number seed value provided by IDEA. This number is used by IDEA as a starting point for the algorithm to calculate the random numbers. If the sample needs to be extended, then entering the same random number seed, but with a larger sample size, produces the same original selection plus the required additional records. Accept the default values in the starting record number to select and the ending record number to select fields. Leave the Allow Duplicate Records checkbox empty. Click Fields to pick and choose which fields appear in the output database. Values highlighted in blue are selected. To remove an entry, click it. Click OK to return to the Random Record Sampling dialog box. Provide a name for the new database you're creating. I'll call mine Sample of Customers. And click OK to run the sampling task. The new Sample of Customers database is now the active database and is shown as a child of the customer database. There's also a new field been added called SAM-RECNO, which stands for Sample Record Number. This is the record number in the master database. In other words, record number 1 is record number 21 in the customer database. To close the Sample of Customers database, click the X in the Database tab. Random sampling, as we have seen, is one method of extracting data. This section will look at direct extraction. Direct extraction involves entering a set of criteria or conditions, and all records which meet those conditions are extracted to a new file. For this example, I want to create a new database of customers who have credit limits of $30,000 or greater. To start, ensure that Customer is the active file and Data is selected in the Properties window. Next, click the Analysis tab and select Direct in the Extract group. This is the Direct Extraction dialog box. Start by giving a name to your new database. You do that by clicking in the first row where it says Extraction 1 and typing in a new name. I'll call my file Large Credit Limits. When you tab out of the name field, you go to the Criteria field. If you know the exact equation you need to get the filtered records, you can go right ahead and type it in. Otherwise, use the equation editor. The equation editor is launched by the button between the file name and criteria that looks a little like a calculator. So remember, I'm looking for customers who have a credit limit of $30,000 or greater. That can be expressed by this equation. To generate that equation, you can either start by typing credit limit in the equation box, or you can scroll through the field list and double-click it. I prefer typing. And as I type, a list of potential fields is displayed. Click Enter to have IDEA fill in the value for you. Next, you either type or select the comparison indicator, so it's greater than, and then enter the value you are comparing your data to. In this case, 30,000. You don't need to add currency indicators or thousand separators here. Just put in the number. In order for IDEA to run the extraction, your equation must be valid. You can use the equation editor to validate your equation by clicking the Validate button. If your equation is correct, you'll get a message indicating that it is indeed a valid equation. If there's an error, the message box will indicate either a type error or a syntax error. Type errors are when there is a data type mismatch, for example, trying to add or subtract numbers which are stored as character data types. Syntax errors are errors in equations, things like missing operators or an extra bracket. My equation is fine, so I'm going to click the Validate and Exit button on the toolbar and return to the Direct Extraction dialog box. The equation is now visible in the criteria line. You can keep creating extractions if you wish by clicking into the next available row and entering a new set of criteria. You can have a maximum of 50 extractions run against a database at one time. When you're done, click OK. The new database opens and is the active file. To close this file, you can click the X in the Title tab. You can right-click on the Title tab and select Close, or you can choose to select Close All. I'm going to close them all. The next several sections will deal with executing specific tasks which are commonly used in data analysis. The first one we'll look at is called summarization. As the name implies, summarization is about adding things up or getting a sum or total from your data. The first thing I'm going to do, using the sales transactions database, is generate the transaction totals for each customer. To start, ensure the sales transactions database is open and that data is selected in the Properties window. Next, select the Analysis tab and in the Categorize group, click Summarization. This is the summarization dialog box. The first thing I do is select which field I'm summarizing and which field I'm totaling. You can select up to 8 fields to summarize. In this example, I'm only looking at account totals for each customer number, but I could get a lot more granular by adding more in the Fields to Summarize list to let me see the totals for each customer number broken down by product code and maybe payment type if I wished. For now, I'm going to keep it simple and just show totals for each customer. So I'm going to summarize by customer number. I only have one option for my total, which is amount. The default action here is to provide a sum or total of the fields selected in the numeric fields to total window, but there are other statistics which I could choose to include. I can also pick and choose which fields will be added to the output by clicking the Fields button. Currently, no additional fields are selected. This helps keep the output clean and easy to read. Click the X or the OK button to return to the summarization dialog box. Next, select the Use Quick Summarization checkbox on the left-hand side of the dialog near the bottom. This allows the task to run faster, but it does impose some limitations on the task's functionality. For example, you'll be restricted to data sets which have a maximum of 4,000 unique keys to total. You're restricted to only using the sum statistic. The others will be grayed out, and you can only summarize on one field. Finally, provide a name for the new database you're creating. Call it Summarize Transactions and click OK. So let's have a look at the new database. You can see that it is summarized or grouped by customer number. There is a new field called Number of Records, which shows how many transactions or records each customer had, and a field called Amount_Sum, which is the total amount of each customer's transactions. Notice that the values in the Number of Records fields are blue. These are clickable links which provide drill-down functionality to let you see all the records for each customer. So this is the record for the first customer, and these are the records for this customer. If I find someone who has particularly interesting information, I can save the details as a new database. I can print them if I wish, or I can close the window by clicking Done. Stratification is a tool for profiling your data by breaking it up into bands. In this exercise, we're going to look at the data to get a sense of the number and value of customer accounts. Begin by ensuring the Summarized Transactions database is active and that data is selected in the Properties window. Before we start the stratification process, we need to have a sense of the range of values in our data in order to determine what an appropriate size for each band is. We can get this information from the field statistics. In the Properties pane, click Field Statistics to create them and have a look at the values which show in the Amount column. When you're finished, return to the Data view by clicking Data in the Properties window. If you only want to see a subset of the field statistics while viewing the data, you can right-click anywhere in the data and select Show Field Stats. Then pick and choose which values you want to see. I'm going to select Net Value, Absolute Value, Average, Minimum, and Maximum, and then click OK. These values are now shown at the top of the file. I can see that the total value of the amount field is 6.4 million, but more than half of that is contained in one transaction showed in the maximum value. The average value is only 21,000. This means that I don't need to stratify my data all the way to 6 million. I can stop well before that and have that one transaction remain an outlier. So to perform a stratification, go to the Analysis tab and click Stratification in the Categorize group. The first box asks me which field is being stratified or broken up into bands. That's amount_sum. Next, indicate which field is being totaled. Select the number of records. The third part is you must indicate what stratification interval is being used. The default value is 10,000, but this can be changed. So I'm going to change this to 5,000. Now to build the strata. The first value of 0 is determined by the minimum value in your database. This can be changed if you wish, but for this example we'll leave it. Next, click in the upper limit column to write in the value for the strata. Click in the upper strata of the second row. Click in the third row and drag it to the fifth. So you should now have from 0 to 25,000 filled with increments of 5,000. Now we're going to change that increment to be 25,000. Go back to the bands and click in the sixth row and drag until the 12th. You should have values up to 200,000. Ensure the Create Result checkbox is selected and provide a name for your result set, such as Numeric Stratification, and click OK. The output this time is not a database, but is called a result set. Here you can see the distribution of records. There are 219 records in the first band, which represents 72% of all the records in the database. There is one upper limit exception. If we click the link, we can see that it's that one large transaction mentioned earlier, so this exception is not unexpected. As mentioned, this is a result set, not a database, so there are some things you need to know. First, this is part of the database which was used to create it, not a child, so a new database is not generated. Instead, an entry is visible under Results in the Properties window. Additionally, there are graphing capabilities here that are not present in a regular database. Click the Graph button in the Results Set toolbar. Each bar is a strata. The number of records is indicated on the y-axis, with all the strata spread across the x-axis. If you hover over any of these bars, you can see details about the strata, such as the number of records and which stratum it is. If you click a bar, you'll get a menu to extract data to a new database, to display the records, or to display the field statistics of that particular stratum. You can change the chart type by clicking the Gallery button and selecting the chart you want. You can also add a 3D effect and change color palettes as well. Experiment here. When you're finished, you can return to the results set by clicking the Alternate button again, or you can return to the data in the Summarized Transactions database by clicking Data in the Properties window. When you're finished, close any open databases. A pivot table is another means of profiling data in a tabular format. In this example, I'm going to create a table showing the different payment types used for each product code as well as the sales totals. Start by opening your source file, which is Sales Transactions Database. On the Analysis tab, in the Categorize group, select Pivot Table. The first thing you're asked to do is provide a name. I'm calling mine Sales Transactions Pivot Table. When you're done, click OK. The creation of a pivot table in IDEA is graphic, so all you need to do is select the field you want from the field list box and drag it to the appropriate location on the pivot table. Start by clicking Pay Type and dragging it to the row header where it says Drop Row Fields here. Next, click Product Code and drag it to where it says Drop Column Fields here. Now we drop the data in the middle. Since I want to see the sales totals, click Amount and drop it in the middle where it says Drop Data Items here. Notice that you can see a subtotal for each payment type in the far right column and the totals for each product code along the bottom. The bottom right square is the sales total amount of 6.4 million, which is what I expect to see here. By default, the values in the data grid are totals, but this can be changed by right-clicking in the grid to open the Pivot Table Field dialog box, and I'm going to change my display from Sum to Count. To view the records which make up a specific group, highlight the cell. You can pick either a data cell or a total cell for this, and click the View button on the Pivot Table toolbar. For example, these are the 4 records for product code 2, paid for by Amex. And these are the 4 records for product code 3, paid for with cash. You can also have more than one field in a row. If it isn't already open, open up the pivot table field list and drag sales ID to the column area, dropping it just to the left of the product code field. This shows me the same information, sales totals by payment type, but is now further broken down by sales rep ID. I can filter my results by either the row or column headers by clicking the drop-down arrow beside the header. So for example, say I want to see only the results pertaining to product code 2 and 4. I'd click the first checkbox. This will clear all the boxes, and then I'll select the items I want to see, product codes 2 and 4. The focus is still on sales rep, but each sales rep's detail can be collapsed by clicking the plus or minus box. To collapse them all, right-click on the sales ID header and select Collapse All. A pivot table is a type of result output, so like the stratification result, it does not generate a child database, but rather is a view of the parent data. To return to the regular data view, click Data in the Properties window. When you're finished, close all open databases. Sometimes the data you need is spread across 2 or even more databases. While it's possible to split your screen to have a horizontal or vertical view of the data, it's often more convenient to simply join the databases together to make a new file. Here's how you do it. Open the database, which will be your primary file. In this case, I'm going to use the Summarized Transactions database. Now, open the customer file and split your screen horizontally. I can see by looking at these files that they both have a customer number field. This is called a key and is the data I'm going to use to establish the join between these 2 files. In order to do this, I need to ensure that both of these fields are the same data type, meaning that they're both character or both numeric or whatever. Hover your mouse over the field headers in each file to see the data types. In this case, they're both character, so we can proceed with establishing a join on this field. Ensure the focus is on the Summarized Transactions database by clicking the Header tab, and then click the Analysis tab and click Join in the Relate group. The Join Databases dialog appears. Ensure that you have Summarized Transactions as your primary database. In the Secondary Database area, click Select to choose which file you are going to join to the Summarized Transactions. We want Customer. Select that file and click OK. You have the option to pick and choose which fields will appear in your output by clicking the Fields button. All fields are selected by default. Next, provide a name for your new database. I'll call it Customer Balances. Next, you need to tell IDEA which field to join the files with. Click the Match button, and in the primary field, select Customer Number. Do the same in the secondary field. Note that the field names do not need to be the same, but the data type does. Click OK to return to the Join Databases dialog. Lastly, you need to define what kind of join you want IDEA to make. There are 5 possibilities, which are best explained by hovering your mouse over each option and studying the Venn diagrams and explanations which appear. Select the All Records in Both Files option and click OK to complete the join. Your new file should have 351 records. I mentioned the history earlier in this video series and said that it keeps a record of everything which is done to a database. Let's open that up and see what it looks like, as well as some of the other information you can get from it. With the Customer Balances as the active file, click History in the Properties pane. Expand each section of the log and see what kind of information is available. So this is where we joined the 2 files. I can see that there are 351 records, that I have 10 unmatched records in the primary file and 48 unmatched records in the secondary file. The primary file was Summarized Transactions and the secondary file was the Customer Database. This means that there are 10 records in the Transactions file for customers who are not in my Customers file. The 48 unmatched secondary files are not as alarming. They indicate customers who have no transactions in this period. Have a look at the IDEA script code section of the history. If you need to perform this join task again, you can use this section of code to create a macro to do so. Click Data in the Properties window to return to the data view. You've used the history to learn more about your data, and now you want to examine the data to see the unmatched records. Find record number 9. Note that customer_number 1 field is empty. IDEA has a feature called Display All Records Containing, which will help you identify all similar records. Right-click in the empty space under Customer Number 1 and select Display All Records Containing and empty brackets. A dialog box appears. This dialog works much like setting filters in the equation editor, but provides an interface to help build the equation. Click OK. You now have a subset of your data showing the 10 records which didn't have corresponding entry in the customer database file. Note that the criteria you built in the dialog box is also visible in the Properties pane. If you wish, you could save this file. For now, I'm going to return to the complete data set. Right-click on the criteria link in the Properties window and select Clear. Repeat the process of isolating records by finding all customers with no sales in the period. Right-click on any record in the Amount Sum column. Ensure the operator is the double equals sign and make sure the value entry is 0.00 and click OK. You should have 49 records as indicated at the bottom of the IDEA window. One of the key features of IDEA is that data is protected once it has been imported. You can't change it, edit it, or correct any errors which you may find. What you can do is add new fields to test and validate data. I want to use IDEA to generate a new credit limit showing a 10% increase and then check to see that no customer has a balance greater than the new credit limit. I'll start by creating a new field for this new limit and we'll compare the current balance to this new value. To start, let's make a new field. Ensure the customer balances database is active, data is selected, and that any criteria from the previous exercise has been cleared. Click the Data tab in the IDEA ribbon and in the Fields section, select Append. Enter a new name for the field, such as New Limit. Accept Virtual Numeric as the field type. Length is not required for a numeric field, so skip this step. It's a numeric field, so we use 2 decimal places, and in the parameter field, you need to enter the equation to add 10% to the existing credit limit. The equation for this is credit limit times 1.1. In the description field, type Updated Credit Limit and click OK. The new field is added to the right side of the data. It is a different color to distinguish it from the data which was imported and is protected. Now, let's compare the current customer balances against that new value to ensure that nobody has a balance which exceeds that number. In the Analysis tab, click Direct in the Extract group. Call the new database Exceeded Credit Limits, or something similar. Click the Equation Editor button and enter an equation to compare the new fields. Something such as Amount Sum is greater than New Limit. Click Validate and Exit to return to the Direct Extraction dialog and click OK to finish running the extraction. The new database contains 11 records. The 10 entries for which we don't have records in the customer file, so there's no credit limit to compare against, and one other who has actually exceeded her credit limit. When you're finished, close all the open files. Testing for duplicate entries is a standard analysis test in IDEA. Here's how it works. To start, open the Sales Transactions database. On the Analysis tab, in the Explore group, select Duplicate Key and then Detection. The Duplicate Key Detection dialog opens. Keep the default selection of Output Duplicate Records. In order to search for duplicates, you need to identify which fields you want IDEA to search in. Click Key and select Invoice Number from the field list. You can search up to 8 fields for duplicates. Click OK to return to the Duplicate Key Detection dialog. You can use the Fields button to refine what fields show up in your output. You can define criteria to further refine what shows up in your output. For this example, I'm not entering a value in criteria nor changing the fields. Lastly, provide a name for your new file. I'm calling mine Duplicate Invoices and click OK. There were 4 results which showed 2 duplicates for invoice numbers ending in 97 and 2 duplicates for that ending in 350. Note that IDEA does not strip these records from the dataset because that would violate rules about not deleting any data. Another commonly performed test is to check for gaps in sequences of numbers. Series such as purchase orders, invoice numbers, check numbers, and this sort of thing are typically sequential, and any gaps should be accounted for. To test for gaps, we'll run a task called gap detection. Start by opening the sales transaction database. On the Analysis tab, in the Explore group, click Gap Detection. Gap detection can be run against character strings, number sequences, and dates to search for missing information. In the Field to Use drop-down, select Invoice Number. This is a character string, so we're verifying against the mask indicated in the model. Ensure the Create Result checkbox is selected and provide a name for the result, such as missing invoice numbers. Click OK to start the process. The result set indicates that there are 2 missing invoices, one ending in 98 and one ending in 351. As an analyst, you'll want to investigate this and find out what happened to these 2 invoices. Previously, we looked at criteria to filter records and direct extraction to pull records which met conditions we provided. In this exercise, we'll look at key value extraction, a visual method of building extraction criteria to see a list of payment types and product codes. Specifically, I want to see transactions for product codes 5 and 6 paid for by Visa. To start, ensure the Sales Transactions file is active, the data property is selected in the Properties window, and that no criteria are in place. Next, click the Analysis tab and in the Extract group, select Key Value. The Key Value Extraction dialog appears. You can choose to use an existing key, or, to build a new key, click the Browse button. In the first row, enter payment type. And then in the second row, select Product Code and click OK to return to the Key Value Extraction dialog. You are now presented with a list of all the payment types for each product code. As mentioned, we want to see Visa payments for product codes 5 and 6. It would be faster to clear all the entries and pick these 2 out of the list rather than deselect each entry one by one. So click the Clear All button and then scroll to the bottom to find Visa plus 05 and Visa plus 06. The default behavior for this dialog is to generate a separate database for each key combination selected. This can be changed by clearing the Create Separate Database for each unique key checkbox. Click OK to generate the output. 2 new databases are created and visible in the File Explorer. The first one is opened up in the database window. KeyVal equal Visa plus 05 isn't a great name, so let's change this. Close the file in the database window and right-click on the file name in the File Explorer. Select Rename File and enter a new name such as Visa Payment for product code 05. Do the same thing for 06.